We have made it to the very last lesson in Module 9. It's going to be Lesson 6, which covers the volume and surface area of composite figures. Now, the textbook is claiming this is only going to be a 45-minute lesson, which would be very refreshing after how rough the last couple lessons were, but somehow I have my doubts. There's only 10 resources in it, but that strikes me as a pretty tough concept. Let's see what they have to say. Bat houses provide a safe place for female bats to raise their young. Bat houses should be placed on a pole or building that is 15 to 20 feet in the air. Your science class is planning on building 8 bat houses to place around the school grounds so you can observe the bats. How can you determine how much wood needs to be purchased to build 8 bat houses? These are some of the questions we're going to answer in this lesson. Incidentally, bats are wonderful things to have in your area because they eat lots of mosquitoes. They're not vampires. They don't suck your blood. Just don't touch them because there is a high incidence of rabies in bats. But beyond that, bats are wonderful to have around. Now, the textbook tells us that the volume of a composite figure can be found by decomposing the figure into solids with volumes you know how to find. So here you can see you've got this house where you have a square prism and a triangular pyramid on top. And if you were to take and decompose them, what would happen is you would end up getting a square or rectangular prism and a square pyramid as 2 separate individual pieces. You would have to find the volume of each one of those pieces, add it together, and you're done. You have found the volume of the composite figure. So here we have a toy block that has the dimensions shown, and you can see that the little kid made their little toy block house out of it. They want to know what is the volume of the block. Round your answers to the nearest hundredth. It is a square base. In fact, it is a perfect cube on the base, and then you do have that triangular pyramid on top. Let's see what they say about solving it. We may go with it, we may not. First off, the 3-dimensional figures in the toy block that can be composed is going to be a cube and a pyramid. Check that. That checks. You got those 2 separate parts. Next, we're going to take and say that the volume for the area of a cube is going to be side times side times side, which I've taught you base area times height, which I really prefer for my volume, but with this being a cube, there's no reason not to do the side cube because it's just really simple that way. And side cubed ended up being the 8.4 cubed, which was a 592 7/10 or 70/100. The volume of the pyramid was 1/3 base area times height, where they took and had the base area is a square, which is side squared. Once again, I would really prefer to see you work out the base area like I taught you, times the height. So 8.4 squared times the height of 5.8 divided by 3 for the 1/3 gave them the 136. So the volume of the cube is going to be about 592.7 cubic centimeters, while the volume of the pyramid is going to be about 136.42. Check those. They both check. Next, all we have to do is add those values together. So let's take a minute with our calculator and do just that. 592.7 plus 136.42 equals, and we get a final answer of, rounded to the nearest hundredth, 729.12. Check, and the problem checks. Really not that hard to do these. That one was a really simple one. Somehow I doubt they're going to give us all of them that are going to be that simple. Now it's going to be your turn to do extra example 1, where you have a rectangular prism and a triangular prism that you have to find the area of, add them up together. Go ahead and find the volume go ahead and find the volume like I taught you to. Find your base area first, and then find the volume after that for each part. That's how I'm going to show you the work. Alright, the first piece I'm going to focus on is going to be the base of the rectangular prism, the base area of it. So we're going to start off with a formula that says base area is equal to length times width, and the length and width I'm working on is these two numbers here. So base area is equal to 2.5 times 2.75. Grab up that calculator again. 2.5 times 2.75. That's going to end up getting us, oops, the calculator didn't come. Where did it go? Let's try that again. 2.5 times 2.75, and now we have 6.875. 6.875 is going to be the base area. We're going to circle it, not because it's the answer, but it is an important sub-answer. Now we're going to find the volume of that rectangular prism, which is base area times height. We established that the base area is going to be 6.875, and the height is going to be that number right there. It goes on that side, 1.6. So the volume of that rectangular prism, bring our calculator back up, times 1.6 equals, is going to be 11. That was super easy. Now we're going to focus next on our triangular prism. The base is actually going to be this triangular piece right here. Remember, the basis in a triangular prism is going to be the triangular faces. And that's where we're going to start with the formula. Base area is equal to base times height divided by 2. So on my triangular prism, if you take a look at it, this number right here, 2.5, is the same length as that side right there. So I'm going to have a base of 2.5 divided by 2 and times, and the height is going to be this number right here, which is going to be 1. Now I can do a real simple simplification here, dividing by 2. 2 goes into 2 once, and 2 goes into 1, 0.5 times. And now I can easily multiply and get straight to my answer of 2.5 times 0.5. I don't even need a calculator for that. That's going to be 1.25 because it's saying what is half of 2.5. Now I'm going to circle that, and I'm going to find the volume of my triangular prism, which is going to be the base area times the height. We already know that the base area is going to be 1.25 times the height is this distance right here, which is the same as that number right there, 2.75. Therefore, the volume is equal to, I'm going to jump back over to my calculator, 1.25 times 2.75 equals 3.4375. 3.4375. And we're going to circle that. Now, all that's left to do is add those two pieces up. So I have an 11.0000 and a 3.4375 for my two volumes. Those are added real simply, and when we get done, we're going to have 14.4375, which means we're going to round to the nearest hundredths of about 14.44 or 14 and 44 hundredths. Jump back over to our textbook, which is right here. Test our answer, 14.44. Oh, no, it said nearest tenth, so that's just going to be 14.4. Check it, and our answer checks. All of this, that's the good supporting work that I'm going to be looking for on your homework for you to get credit for it. Now we get to watch a video from our sponsors on how to find the surface area of a compound figure.
To find the surface area, first decompose the composite figure into simpler solids. This figure is composed of a rectangular prism and triangular prism. Next, find the surface area of the simpler solids. Do not include any faces that are not exposed in the original composite figure. The first solid is a rectangular prism. Since the top is not in the original figure, find the areas of the remaining surfaces. Then find the sum of the areas to find the surface area. The second solid is a triangular prism. Since the bottom is not in the original figure, find the areas of the remaining surfaces. Then find the sum of the areas to find the surface area. The surface area of the first simpler solid is 294 square feet. The surface area of the second simpler solid is 102 square feet. So the total surface area of the composite figure is 294 plus 102, or 396 square feet.
Well, they blew through that pretty quickly, and I'm not terribly pleased with how they showed their work on it. We get into actually doing our last couple of problems here. We've got example 2 and extra example 2, and I'm thinking those are going to be pretty time consuming to show, so we're going to go ahead and stop this video and come back on part 2 where we're going to continue this problems.